Alright, so third part of this video. Alright, so we already did this one. Force acting on a body in a same direction will get added. So if the force is acting in the same direction, in that case, both the forces will add. Now, two forces acting on a body in opposite direction. So there's a box and one person is pushing from here, the other one is pushing from here. The resultant force is in the direction of larger force. Suppose this person has a greater strength. Okay, so suppose we represent with two arrows, and he has less strength. In that case, the box will move in this direction. However, his strength, okay, will be subtracted from this one. All right. So total force acting on a body in opposite direction, the resultant force is in the direction of larger force. So the resultant force. So this force is a resultant force. So box will be moving in this direction. That would be the result of it. So that direction would be towards the larger force. Okay. All right. So the force will be added. No. Okay. The resultant force would be in the direction of a smaller force. Of course not. Okay. Because the larger force will overpower it and it will move in this direction. Hence, the answer is the first one. Two forces equal magnitude acting in opposite direction. Now over here, box is there and two people with same strength, they are pushing it from both the sides. In that case, force will get added up. No, it will get subtracted. Both. No. So in this case, either added or subtracted, nothing will happen. This box, since forces have been applied equally, there will be no change. Okay. The body, the direction, it will remain stationary over there. It will cancel the forces. Both the forces will get cancelled because they are equal in magnitude and opposite in direction. So they'll get cancelled. Hence, there will be no change. Okay, 1 kilogram force is equal to how much Newton? So it is 9.8 newtons. This is the force with which Earth pull all the objects. So remember this, 1 kgf is equal to 9.8 Newton. Okay, a body not changing its position with time with respect to its surrounding, okay, is said to be, now this is a definition. If a body is not changing its position, that means it is at one place, it is not moving anywhere. We call it, it is at rest. Okay. For example, a book is kept on a table. It will not move unless someone picks up or pushes or do anything to that book. Unless you apply some forceful or push to it, it will remain over there. Okay, at respect to its surrounding. So it is said to be stationary. Okay, it is said to be at rest. So the answer would be at rest. Now, body changes its position with time with respect to its surrounding. So with the surrounding, if it is changing its position, we say that the body is in motion. All right. This is a definition for rest and motion. We can increase friction. Okay, how we can increase friction? By using lubricant? No, by using lubricant, it will become smooth and it will reduce friction. By smoothing the surface? No. Using ball bearings? No, it will reduce friction. So by increasing weight, yes, if you increase the weight of the object, in that case the friction will increase. So the answer is D, by increasing the weight of the object. Body of an aeroplane is streamlined. Okay, now it is streamlined so that it can easily cut through air. Okay, so that's why especially fighter planes, they are like pointed nose, or even in flying aircraft they have, so that they can, air can easily pass through it, all right. So body of an aeroplane is streamlined to reduce friction. Okay, so answer is A, that is to reduce friction. Friction produces heat. Okay, so whenever you rub your palm, that means you're creating friction. In that case, it heats up. So friction produces heat. Ball bearings are used to reduce friction. So ball bearings we use to reduce friction. The maximum force exerted by a surface on a body so long as it remains stationary. Now this is a definition for static friction. Okay, so maximum force you exerted by the surface on a body. Suppose a box is there. So surface will try to hold it, okay, keep it with it because of friction, because it's contact force called friction on a body, so long as it remains stationary. So you're trying to push it, but it is stationary, it is not moving. Till the time it is not moving, okay, or the maximum force till it is not moved, it is called as static friction. Once it starts moving, okay, the example would be again a bed or a table. If you're trying to push it, so initially you have to apply more force to just move it. That maximum force required is called as static friction. Now once it starts sliding, okay, it is called as sliding friction, wherein, so this is the definition for sliding friction: minimum force required to keep a body moving over a surface where it covers equal distance in equal interval of time. Now once it starts sliding, your bed or table, it moves smoothly, okay, so it covers equal distance in equal interval of time, it moves with a uniform speed, okay, a uniform motion, it performs a uniform motion. All right, so that is called as sliding friction. Okay, now if you put the same thing on a roller, it becomes a rolling friction. So example is minimum force required to roll a body on a surface is called as a rolling friction. All right, that's it. Bye.